Hello, this is the lesson on systems of three variables word problems. So we're just going to go through several of these and hopefully by the end you'll have a better feeling for how to do them. It says, number one, Billy's restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. How many of each type of flower was ordered? So in all of these, the question is given. Even if the question wasn't given, remember you're trying to get three equations of three unknowns. And the reason I know that it would be flowers each type is because I've got a total of 200 flowers, and the types of flowers here, there's three types: carnations, roses, and daisies. Second thing is I'm not going to use X, Y, and Z because when you get to these more difficult word problems, it just helps my brain to have the same letter as the what we're looking for. So I'm going to define my variables this way. I'm going to let C equal the number of carnations. I always put the unit because this might be dollars sometimes. So I'm just thinking these are the numbers of carnations. I'm going to let R equal the number of roses. And I'm going to let D equal the number of daisies. So I have three unknowns. That means I need three equations. Now, to me, two of the three equations are easy because I have totals. The third one is going to be a little trickier. Okay, so they ordered 200 flowers. Well, we know that this is flower, flower, flower. So C plus R plus D would equal 200. So anytime you're given a total, this is a total flower equation. And then down here, we have a total order in total money. And we were also given how much each of them cost. So it's $1.50 per number of carnations, so 150C, and then roses are 575, so that would be 575R, and then daisies are 2.6D, and that total money amount is $589.50. Okay, now this last equation is a little harder. I call them comparison equations, so you want to be on the lookout for comparison equations. And I have a particular way of doing this that hopefully will help you. And it's this sentence right here. It says they ordered mostly carnations. Okay, well, that's a throwaway. Okay, great. But here's the comparison right here. They ordered 20 fewer roses than daisies. And sometimes that can get a little confusing for students. Where does the 20 go? You might know you're either going to add 20 or subtract 20, but sometimes it's a little tricky to know where that 20 is going to go. So I call these comparisons because we're comparing roses and daisies. And what I do, some people don't have a hard time if I'm in class. A lot of times there'll be one person that knows what to do right away. But what I do is when I'm comparing roses and daisies, for example, I put the roses variable on the left and the daisies variable on the right. And then I just use reading comprehension, and I just say, who needs the help? Who needs the help? So when I read 20 fewer roses than daisies, I know that I bought fewer roses. Roses is less than daisies, but I'm saying they're equal. So who needs the help? Well, roses is 20 fewer, so roses needs the help, so I'm going to add 20. Now we're going to use our calculator, so next we want to make sure all three of these equations are in standard form. And it doesn't matter that I'm not using X, Y, and Z. I can just remember C was first, R was second, D was next. So that equation is fine. That equation is fine. This one, I don't have a C term, so that's going to be 0C. And then R is already on the left, so that's plus 1R. And then D is on the right. It needs to move to the left, so that's minus 1D. equals, and then 20 is on the left, it needs to move to the right. So that would be negative 20. So now I can pick up my calculator. So I can say system solver and number 2. And then I'm just going to type over these. My first coefficients are 111 and 200. So 1, enter, 1, enter, 1, enter, 200, enter. Second row would be 1.5, 5.75, 2.6, and 589.5. Okay, now the third row is going to be the coefficients from the third equation, which would be 0, 1, -1, and -20. Then I hit solve, and your calculator is going to say X, Y, and Z, but you know that's C, R, and D because that's the order we typed it in. So X is 80, that's number of carnations. So 80 carnations, and then we hit the down arrow, and we get Y equals 50, but we know Y is the R for 50 roses. And remember, 20 fewer roses, so sure enough, there is Z is 70, so daisies is 70, 70 daisies. All right, let's take a look at number 2. So number 2 says, the arcade in Lynchburg, Tennessee uses 3 different colored tokens for their game machines. For $20, you can purchase any of the following mixtures of tokens: 14 gold, 20 silver, 24 bronze, or 20 gold, 15 silver, and 19 bronze, or 30 gold, 5 silver, and 13 bronze. Again, the question helps us. And it's different than this one because it says, what is the monetary value of each token? So we know we're talking about 3 different tokens, but and I'm going to let my variables be G, S, and B. But this is why I don't recommend you just say G is for gold. Okay, because G doesn't stand for the number of gold coins, like gold tokens like it did up here. It stands for the monetary value. So the monetary value or dollar amount for a gold token. And S is going to be the dollar amount for a silver token. So I like to make sure I put my units there because sometimes it's money and sometimes it's number. B is going to be dollar amount for the bronze token. Okay, now I have 3 unknowns, so I need 3 equations. And then you're still looking for totals, but this time it's strange because all 3 equations are going to total $20. Okay, so the first equation, 14 gold tokens times their money amount, is going to give you some money, plus 20 silver tokens money amount. So 20 tokens times the money amount that you're using for a silver token, plus 24 bronze times their money amount is going to equal $20. So we have money plus money plus money. And the same thing for the next one, 20 gold, 20G plus 15 times S plus 19 times B equals $20. And 30 gold plus 5 silver plus 13 bronze equals $20. Okay, now I'm going to take this all the way through so you can see what's going to happen with the values. And so I'm going to put this in 14, 20, 24, 20, 20, 15, 19, 20, 30, 5, 13, 20. Okay, so X equals 1/2. This is another reason why you want to think about what G or X is. It's not half a token, it's the money amount, and it's in dollars. So 1/2 is 1/2 a dollar or 50 cents. So you have to interpret what the calculator is telling you based on what you've thought about. All right, Y is 7 over 20. So 7 divided by 20 is the decimal 0.35. So silver tokens are 35 cents. And last, I will see Z is 1/4 or 0.25. So bronze are worth 25 cents. Okay, I think you should try the third one, but I will give you a little warning. There is another comparison equation you're going to need to write. So pause the video and try it. Okay, so I let M equal number of matinee tickets, S equal number of student tickets, R equal number of regular tickets. You get points for that on the test. Make sure you write that down. And then I looked for total amounts. I have a total of 8,500 movie tickets. So one equation would be M plus S plus R equals 8,500. And then I have a total money amount equation. So one equation would be 5M plus 6S plus 850. I forgot the R. 8.5 R here equals 64,600. And then I thought we would do this one together. Third equation, twice as many student tickets were sold as matinee tickets. So I'm comparing student tickets to matinee tickets. And I say, who needs the help? When I read this, twice as many student tickets. Wow, that's a lot of student tickets. So we need to help matinee tickets. And twice means 2 times. So we're going to multiply matinee times 2. Okay, so then remember you want to get this equation written just like these. So I'm going to need to move the 2m over. It becomes a negative 2m. The s is already on the left, so that's 1s. And there is no r, so that's just going to be 0r. And then when you move this over, there's nothing on the right, so you just put equals 0. So if you put that in the calculator, I'm going to pause and go ahead and do that and then reveal the answer. Okay, so I have it all in and I hit solve. I get X is 900, Y is 1800, and Z is 5800. So my X is matinee, so 900 matinee tickets and 1800 student tickets, because that was the second variable I put in. And then Z 5800. So 5800 regular tickets. And I can check part of this, see how matinee is 900 and twice as many would be 1800, and they add up to be 8500. All right, the next one can be really tricky. These table ones can be tricky to understand. I'll just read it and then we'll talk about it. It says Kitchen Corner produces refrigerators, dishwashers, and ovens at 3 different factories. And the table gives the number of each product produced at each factory per day. So this table is saying that you make 8 refrigerators at factory A, 10 refrigerators in factory B, 14 refrigerators in factory C per day. All right, Kitchen Corner receives an order for 110 refrigerators, 150 dishwashers, 114 ovens. How many days? See, that's what's tricky, is that you've got refrigerators, you've got A, B, and C, but we're looking for the number of days each plant should be scheduled to fill this order. So it's kind of tricky to read this. Do you read this way, 8, 16, and 10? Or do you read this way, 8, 10, and 14? Well, the answer lies in the total amounts, very similar to these other problems, except here they are. There's a total number of refrigerators to be made, and there's a total number of dishwashers to be made, and there's a total number of ovens. So I like to name my equations. Like up here, that was a total ticket amount, and that was a total money amount. So I have a ticket equation, a money equation. Well, I'm going to do the same thing here, and that's what's going to help me get over the hump. I need a refrigerator equation. So if I need a refrigerator equation with a total of 110, that I need everything to be refrigerator, refrigerator, refrigerator. So that means I'm going to read this horizontally. Okay, so the first equation would be 8 refrigerators are made in a day in factory A. And let me stop. Let's define our variable. So the question is how many days at each plant. So I'm going to let A equal, remember the units, days. A is days in factory A. And B is going to be days in factory B. And C is going to be days. So the unit is days. All right. So this is a refrigerator equation. So 8A, which represents 8 refrigerators times the days in factory A, plus 10B plus 14C equals 110 refrigerators. And so I even maybe write that down. This is my refrigerator equation. All right, now I need a dishwasher equation. So that's 16A plus 12B plus 10C equals 150 dishwashers. And now I need an oven equation. So that would be 10A plus 18B plus 6C equals 114 ovens. All right, I'm just going to reveal the answer to that in a minute because really we just want to practice writing these equations. Okay, so I put this in my system solver and I got A is 6, B is 2, C is 3. But caution, I would count off here. Anytime you have a word problem, you need units. So the best answer is 6 days. You take that unit and put it with the 6 in factory A, 2 days in factory B, and 3 days in factory C. So make sure you have answers, numbers with units with these word problems. Okay, so we have a different one. This time I'm given a polynomial of the form f of x equals ax squared plus bx plus c, which passes through the point 1, negative 6, negative 1, 2, and negative 2, 3. So with 3 points and systems, you can actually find this equation. The trick is to understand that when you're given these ordered pairs, you're given an x and a y. Call it x1, y1, an x and a y, and an x and a y. And so we want to know the numbers. A, B, and C are the numbers that you get. So in order to get this, we need to understand that this is x and that's y. And so I have an x and a y, an x and a y, an x and a y. So I'm going to plug each of these in and I'll have 3 equations. So the first one, 1, negative 6, would mean that y is negative 6. I don't know what a is, but x is 1. So I'm going to put 1 in for x, square it. I don't know what b is, but x is 1. So I'm going to put 1 in for x plus c. Okay, so if I simplify that out, that's just negative 6 equals 1 squared is 1. 1a plus 1b plus 1c. Now we're going to do this for the second point. That's x and that's y. And so I'm going to put 2 in for f of x because that's y equals a times negative 1, quantity squared, parentheses around that, plus b times negative 1 plus c. So if I simplify that, that's 2 equals negative 1 quantity squared is positive 1. But catch this, b times negative 1 is negative 1b, and then you have plus 1c. So I have 2 equations now. So I just need one more, and I have that third order pair. So that's negative 3 equals a times the x-coordinate negative 2 quantity squared plus b times negative 2 plus c. So that would give me negative 3 equals negative 2 quantity squared is 4, so that's 4a minus 2b plus 1c. So if we put that in the calculator, and do that quickly here, solve again. So this time I have to put the right side in first. So the constant has to always go up to the right of that line. So 1, 1, 1, negative 6. 1, negative 1, 1, 2. And 4, negative 2, 1, and then negative 3. And then when you solve it, you have to remember you're looking for A, B, and C, right? So X is A, negative 3, B is negative 4, and Z is 1. Now, so I wrote that down here, but that's not the answer. It says find the polynomial of the form f of x equals, do that, a x squared, right? So a is negative 3, so negative 3x squared minus 4x plus 1. That's the polynomial. So if you get 3 points on a polynomial, on a quadratic, you can find that quadratic. Okay, last one, you're going to need another formula. Mabry invests $50,000 in money market accounts at 3 different banks. Bank A pays 3% interest per year. B pays 2% interest per year. C pays 4% interest per year. She decides to invest twice as much in Bank A as Bank C. There's another comparison equation you're going to have to write. After 1 year, Mabry has earned $1,630 in interest. How much did she invest in each bank? So before I give you the formula, you should know how to define your variables. You can look at the question, and I'm going to let A be how much, right? So just don't put Bank A. That's the money she puts in Bank A. So B, the unit would be money in Bank B. And C would be money in Bank C. Okay, now for the formula that you're going to need. So this problem is dealing with interest, simple interest. And simple interest is this formula. And it looks really hard, but it's really not. It's what you might do even if you didn't know this formula. I stands for interest. And interest is created by the money that you have. That P stands for principal, so the money that you have, times the rate of interest, which is always a percentage, and then you write it as a decimal, times the time that you have it invested. And T is time, and it's always in years. So if you're given something sneaky like 6 months, that's 0.5 of a year. And so that's the formula that we're going to use to write the second of 3 equations. The first equation, you should know you have a total money amount, $50,000, and money went in A, B, and C. So A, money in Bank A, plus money in Bank C, plus money in Bank B, plus money in Bank C is $50,000. So that's equation 1. Now, notice that you are given a total interest amount, $1,630. So how is interest calculated? Well, the money times the rate times the time in years, and you'll notice that the years are just per year. So we're talking about 1 year. So you're not going to see that in the expression, but the principal, that's money in Bank A. Bank A earns 3%, so that would be 0.03A. And because you have to convert that percent to a decimal. So this one converted to a decimal, if you divide by 100, move that decimal 2 places to the left, that's 0.02.